And well, let's move on to, or let's come back to Australia again. There we have Paul Rowe that is going to talk about Australian Acoustic Observatory. So we
thanks, Diego. Yeah, so it's Paul here, although it says Simon, so I'm using his laptop, so apologies for that. And thanks also to Almo for arranging this wonderful event in difficult times. It looks like I've got less than 1 minute, so I'm hoping I'll get a bit more time than that to present. Okay, but I'll try and leave some time anyway for coffee. So I want to talk about the Australian Acoustic Observatory. This is a big project which we've been running for a couple of years now. I've had a few delays, obviously, due to COVID. It involves a lot of different people who are listed here. We're sort of all in Australia. I'd like to start as is traditional in Australia by acknowledging the traditional owners of the land. So the land where we are now is the Turrbal and Yugara people's land, but the land on which we're collecting data for the Acoustic Observatory is all over Australia. So I'd like to pay my respects to their elders, past, present and future, and to recognise that Aboriginal and Torres Strait Islander people have always been and played an important role in protecting and conserving the land and sea. Okay, so Australia is a large and sort of sparsely populated and mega diverse and unique ecosystem, and we're under threat from climate change, bushfires and invasive species. And even our government has identified that we've got a strong need for sort of scalable monitoring. You know, in some ways it's quite different from Europe. We don't really know what's going on. We've got very little baseline biodiversity data. A lot of my colleagues will sort of go out into the field, maybe just sort of once a year to remote areas to try to understand what's going on. But we really, on the whole, don't know what's happening at other times, and we don't know what's happening at any kind of scale. So there's a real need for scalable monitoring, both to understand what's changing, but also to monitor management actions and restorations and offsets and some of the good work that we're trying to do. If we look at other areas, so if we look in particular at areas like kind of remote sensing and drones, they've really sort of transformed a lot of what's been going on in environmental science. And particularly, they've enabled scalable vegetation monitoring through the sort of collection of these sort of large open access data sets over large periods of time. So Jerome's plenary at the start was you know, particularly sort of appealing and, you know, music to our ears, because this is exactly the kind of thing that we're looking for in acoustics. So the question that this Acoustic Observatory project is really trying to address is to sort of understand and to work out how we can use sort of ecoacoustics to transform fauna monitoring. So essentially what we want to do is to collect, we want to record sound at a large scale to form a sort of a direct and permanent objective environmental record. So that's hence the idea of an observatory, rather like an astronomical observatory. And we want to do that at large temporal and spatial scale. So it's very much along the lines of what Jerome is also trying to do. So the aim of the observatory is not a curated sort of trophy data set. So we're not trying to do something like Xenocanto. It's also not about single species or single questions. So that's quite different from perhaps a more traditional way of doing ecology. In some ways, what we're trying to do is to do a more data-driven version of ecology. So we want to monitor multiple species and to answer many questions. So from an ecological point of view, the kind of things that we're trying to do is to do an inventory, a biodiversity inventory, because we don't really have good baseline data in Australia. We just don't know what's where. We want to understand what's changing. So we want to be able to do the monitoring to understand how the environment's sort of changing, how the faunal environment's changing, and also how it responds to important environmental events like sort of droughts and floods and fires and things, which we sort of had, you know, back in 2019, at the end of 2019. Another another sort of aspect of the observatory is we also want to use it to actually sort of drive further ecoacoustics research. So it's both for answering important ecological questions as well as supporting sort of research in ecoacoustics. So I suppose the questions then are is how do you realize an acoustic observatory? I mean, obviously you've got to find some funding, and luckily this is a sort of sufficiently crazy idea that you can go to funding agencies and get funding for it, and that's what we did. So we got an infrastructure grant for that. Normally it's the physicists and chemists that get these infrastructure grants. So when you get a ecologist and a rather warp-minded computer scientist going to ask for this kind of funding, you do stand a chance, I think, just because it's sort of sufficiently sort of novel. But there are a lot of considerations, and it's really about trade-offs. There are a lot of different ways that you can organize something like that. So I think, as Sandra Muller was saying about looking at some sort of standardized approaches to long-term monitoring, I think that's really important. So for the observatory, we need to think a bit about the number of recorders, recording quality, duration, sampling, storage, and networking, and they all sort of trade off. It's, do you want to have more recorders or do you want to have better quality recorders? The amount of money in the end and resources is always fixed. A kind of another way of viewing it is that what we're really doing is we're building on existing activities. As I sort of said, one of the ways this started was one of my colleagues, Professor David Watson down at Charles Sturt University, who was doing these sort of regular sort of field visits to the Sturt Desert sort of once a year. So we sort of did a trial where we put out some sort of sensors and left them out to see what was happening at other times of the year, and realized this might be a good way to scale monitoring by essentially piggybacking. And by that I mean sort of building on the goodwill of existing activities, because the visiting of the remote sites is something that's really expensive. And so the idea is that if you can kind of leave some of this sort of automated equipment behind to gather data, we can really find out and understand what's going on everywhere. So we want to leave these recorders out. We want them to record for a long period of time. In many of these places, there's no networking, or it's too expensive to sort of do networking. And even if you have got networking, you still need, the recorders need a little bit of maintenance. So, there are more trade-offs there. And really, I think the best thing is just to have dedicated recorders which are not networked and have sort of more of them, which is what we did. But it's very much about running on goodwill. The other aspect of it is that if you get an infrastructure grant, there doesn't tend to be any operational funding to support that. So you need sort of ongoing maintenance and people going out to sort of collect data and things. The recorders we had were a variation on one designed by Frontier Labs, went out to a tender. We sort of balanced the system, and that was another one of these sort of important trade-offs. So we balanced the, if you like, the sort of recording quality and amount of storage. So it would have been nice to have had an open source recorder. We'd have liked to have used something like AudioMOS, but really the sort of the quality and the other bits and the sort of the sort of solar power and robustness, there weren't cases and things around, really sort of precluded that. We wanted a sort of simple deployment. They've got an inbuilt GPS, so we know where they are, and we can kind of synchronize time and things like that. They've got a little AGM battery in them that keeps them sort of running when it's dark. If we deploy them in rainforest areas, then we swap the batteries out sort of once a month. We record sort of continuously, and we're recording just in sort of mono and at 22 kilohertz. That's something that potentially we could change in the future, but I think, as Jerome said in answer to one of the other questions, if we recorded at 44 kilohertz, we'd need twice as much storage, which would probably mean that we'd have to reduce the number of recorders perhaps by 25% or more. So it's all about juggling these trade-offs, and of course they do change because technology is sort of changing. In terms of the sites, we've got about 400 recorders spread across 100 sites. Those sites are spread across, they're sort of meant to be representative of different ecoregions over Australia. They're, slightly biased towards sort of Eastern Australia, as a lot of things are. We deal with a lot of different landholders, and I'll sort of talk a little bit more about that later. So the project's running for 5 years, which I think just makes it a long-term project according to Jerome, which means with 400 sensors recording continuously, flat compression and things, that will result in about 2 petabytes of data. So storage is a big deal for this project, but it's sort of 2,000 years of data, which is kind of cool. all of the data is open access. All of that is open access under a Creative Commons license, and that actually facilitates working with landholders because that was part of the original sort of grant, as part of the contract, and so it's just that's what has to happen. And if landholders, can't manage that, then we, talk to someone else. And a lot of people wanted to work with us, which was great. In terms of the actual sort of design of a site, so we've got about 100 of these sites. Each site comprises sort of 2 pairs of recorders. So we've got a recorder in a wet area and a recorder in the dry area. And something I was really happy about was the thing which Jerome mentioned when he was talking about sort of spacing his sensors about 1 kilometre or so apart is sort of similar to what we're doing. So we want the recorded events to be sort of independent events. We don't want to overhear, if you like, the same call on different sensors. So we've got a little bit of sort of flexibility around that design. The sort of wet sensors near a water course, typically perhaps sort of 50 meters or so away from it. So we're going to get sort of any sort of effects associated with that. And frogs or particular sort of species and vegetation will be there. But essentially it's the sort of same sort of area which is going to be being used by sort of the same or similar species. This sort of design also gives us some redundancy and replication as well, which sort of helps in terms of the different questions that we may want to ask around the sort of the biodiversity sort of inventory, the monitoring, the sort of longitudinal change, and looking at particular environmental events. There's a whole big kind of data management system that we have. I'm not going to go into the details of that, but we've got, database, we've got multiple web servers, we've got a sort of a WordPress front end for all the sort of fancy stuff. That's a lot of work. So as people have mentioned, the sort of data management side of things is tricky, and there's a lot of resources went into that, still are going into that. In terms then of analyzing the data, well, again, as sort of Simon and other people have said, we're adopting different approaches, and I don't think there's a one size fits all here. I think you've got to use different approaches. So we have some citizen science projects, which we're going to be sort of announcing soon. You can kind of manually listen to data. We've got automated detectors where we're using both, detectors that we understand as well as the deep learning ones that we don't, that seem to work well anyway. And of course, the sort of soundscapes. And I think there's a lot to be going through mixing these techniques, so you can actually sort of combine them to work well. And sometimes you need to use things like soundscapes, because if you've got automated detectors, all they can do is tell you whether there's something that looks like it was a particular call, and you don't know anything else. If the microphone fell off, then you'll find that species wasn't there, and so you need something like indices to tell you what's really going on. Here's a sort of set of the sort of deployments sort of over Australia. So various ones there. What I'll do is I'll play you a few sort of sounds. So this is from Samford. This is from near sort of Brisbane. So this is sort of southeast Queensland, reasonably near the coast, I guess, 30 kilometers from the coast or so. And this was sort of a dawn chorus, and it was in August, I think. Anyways, it's in our winter, which is where we are now. I realize I'm not sure if I did this. If we move further, sort of further west, the soundscape changes. So this is sort of Bawra, which is, approximately moving further west, 10 hours west driving. And we can move even further into the desert if we wish to. So let me wrap up soon. I do want to thank all of the different landholders and people who have participated in the observatory. As I said before, it really does rely a lot on goodwill of other people to put out and maintain these sensors. So I want to thank all of the people involved, particularly the traditional owners. As I said, having an agreement already worked out in place in terms of what's going to happen to the data was really, really useful, and particularly having an open access agreement greatly simplified negotiations. We found that with organizations, they were either happy with it or they had a problem with it. If they had a problem with it, it wasn't something we could negotiate on. So it was a great thing to do. I want to thank obviously the lots and lots of people have been involved in this, particularly the QUT Eco-Acoustics group, some of whom have been here. Some of my computer science sort of colleagues at QUT, some of the ecologists I work closely with, like Susan Fuller, and the Acoustic Observatory leads, in particular, David Watson, Richard Fuller, Paul MacDonald, and Lynn Schwarzkopf. It's funded by the Australian Research Council, which was great, in particular an infrastructure grant. So I sort of strongly recommend that if you do want to do these things, have a look at the infrastructure grants and things that are available. Typically, I think they're not grants that ecologists tend to go after. It tends to be the chemists and physicists and engineers who go after these. The only downside to them is that they tend to fund infrastructure, so they don't fund research, and they don't usually have operational funding. Certainly want to thank and acknowledge again all the traditional owners we've worked with. If you want to know more, please get in contact. We've got a paper which is sort of coming out any day now. Yeah, and thank you. I'm happy to take any questions you've got, and hopefully there's still a bit of time for coffee afterwards. Thank you.
Thank you so much, Paul. A wonderful presentation. It was super nice to see all the effort you are doing there. It's just amazing. I think we have a question from Jerome as well. Jerome, please.
Yes, hello, Paul. I'm very pleased to meet you for the first time, even virtually. And it's so impressive, of course. Your project is really, I think, unique and very impressive. I would have very simple questions, but why do you record continuously? Why don't you sample in time?
Well, I guess because we're not sure what we're going to find, and we're putting the sensors out in a lot of different eco regions. The real answer is that in some ways it was the easiest thing to do. I guess it means we get geophony and things. And also what happened was, prior to this, we had quite a large data set. We probably had about at least 150 terabytes of data from many, many projects that we've been involved in ecoacoustics. And my hope was always that we were going to be able to reuse this data, and that there'll be some way to sort of slice and dice the data to be able to reuse the data we'd collected and do something with it. And it was really, really hard because the data had been collected with different protocols, different sampling protocols and things like that in mind. And so it just made it very, very difficult for us to reuse the data which we previously collected. And so really we just decided that for simplicity, it was just much easier to record continuously. The other thing is that in many cases, we just don't know, we just don't have data from a lot of these places. So we don't have this sort of baseline even understanding of the species. So it may be that in the future we could refine things a little bit, but the price of storage is dropping. So, the storing stuff is becoming less of an issue. And I was also guided very much by what I know that the astronomers do, and they're playing a sort of a similar game, which is they know that by the end of a 3-4 year project, the price of the storage will have halved. So they'll be able to take all of the storage that they currently have and put that on to some new infrastructure and still have space for another 3 or 4 years for the same cost that they would have had sort of previously. So the fact that the cost of the storage is sort of halving every few years sort of helps with being able to kind of keep your your sort of system going. I mean, obviously we're going to, you know, in the future, we're going to need to find further funding to store things, but that cost is falling. So I'm not too worried about being able to keep data, but I'm really worried about losing things.
Thank you.
We have a question from Dan Stowell. Impressive project. Do environmental changes, such as climate change, make a difference to the best location for your sensor sites?
I don't think we know. I mean, I think again, we're just trying to collect data to understand those things, but it wasn't specifically targeting climate change.
Another question from Oliver Metcalf. Do you have any thoughts on how to make these long-term, large-scale projects compatible between different devices and over years as TEDS improves? Is there a way to match signal to noise, for instance?
Well, I suppose a tongue-in-cheek way is to say that it's nice if everything is open and we have details of how things were recorded, then I think we will be able to make those comparisons. So I think it does help where we can understand about the characteristics of the hardware. We know what's in it. So we know, for example, that although our hardware is proprietary, we know that, you know, the actual microphone in there is a Primo EM172. We know a bit about the sort of the gain of various things. So I think the first thing is to make sure we've got all of that information. The other thing, as Simon was saying, is that we do find that, and it is a worry, I think, that a lot of our techniques are rather brittle in terms of, we find that if we do inject a bit of noise, or if they're recorded using some different equipment, then we find that, you know, some of the sort of the recognized and even indices can change quite dramatically, and I think that's a concern.
Okay, and the last one, did you have this up and running before the forest fires and in affected areas? It would be so interesting to hear the recovery of those sounds.
Yes, we had some sites out before the fires. In some cases, some of the units some of the recorders were pulled in to sort of save them. So yes, we are interesting. We do have projects looking at the sort of before and after effects of what happens and after bushfires sort of go through areas.
Well, thank you so much, Paul. This was an amazing project, very nice.